Thanks, Lydia, for inviting me. Thanks, Google, and for providing this conference. And thanks to you guys for being here because you really are interested into testing. So first off, why boosting your testing productivity with Groovy? Well, I'm here to tell you that you can have fun while doing your testing. But before we start, how many of you actually are comfortable using Java or use Java for testing? Well, like 70% of you people. All right. How many of you also use another language for testing your Java code? Let's say Ruby, Python, okay, more hands, Perl, the same amount, like 20%, Smalltalk, JavaScript, okay, a few hands. Anybody using Groovy right now? All right, like 10%. Okay. So for those of you guys that are not using Groovy, hopefully I'm going to demonstrate how you can use it to test your Java code in an easier way, in a funnier way, and in a faster way, eventually an agile way. So this is the agenda. What is Groovy? Then we are going to see a little bit of integration of Groovy with some testing frameworks. The testing frameworks of Java are pretty well known, JUnit and TestNG. Then we are going to do some mocking with Groovy. Anybody here knows or will use mock testing? How do you feel about that? Good, bad? Because I know that mocks have a love-hate relationship, right? Then we are going to do database testing. Yeah, databases are very important pieces of code. And functional UI testing. This is another aspect of software testing that usually goes out of this schedule, right? Because UI testing is hard. It's harder than testing a database. It's harder than testing a server. So hopefully we're going to see one of the many options you have for testing UIs, and eventually some resources that you can look afterward. Okay. So what is Groovy? Well, Groovy is an agile and dynamic language for the Java virtual machine. And I'm not saying just agile because of the sake of this is a buzzword. No, really, because it has so many features that you can use right now that we will love to have in Java 7 or Java 8 whenever it comes out. For example, closures. Everybody is talking about closures. Are they going to be on Java 7 or not? Who knows? We have to wait for next year. It builds upon the strengths of Java, but it has its own set of features inspired by other languages like Smalltalk, like Python, and like Ruby. That's why I asked you guys if you knew about other languages, because that knowledge that you have with Java and those other languages, you can apply it right away with the Groovy language. It also makes modern programming features like closures available for you right now in the Java virtual machine, and with an almost zero learning curve, because the Groovy language is very close to the Java language, but it's still its own language. It is not Java++. It is a complete and individual language. And also supports domain-specific languages. So you can create a testing DSL. It is very easy. Actually, we're going to see one of them. And there are many options for you to create a DSL for almost anything. It also increases developer productivity by reducing scaffolding. So, for example, let's follow the Java Beans convention. I hope you guys know about the Java Beans convention. You have to provide no args constructor and a getter and a setter for each property, right? How many lines of code are wasted writing the same things over and over and again just to fill the convention, right? So that is a scaffolding. We all know about that. We will love to have properties in the Java language eventually, right? Groovy provides those features right away. It also simplifies testing because it provides a great integration with a JUnit framework out of the box. And it also provides integration with the TestNG framework out of the box. You don't have to import anything extra once you download Groovy. You just run your test scripts, and you're done. You get your red bar or your green bar, depending if your test is good or bad. It also seamlessly integrates with any existing Java code, Java library, Java object. And that is for a good reason, which we're going to see a little bit further. And it also compiles down to Java bytecode. There are plenty of languages that exist in the Java, in the JVM ecosystem. There are more than 250 languages. And some of those chose to write bytecode, valid Java bytecode. And some of those don't. They don't want to be close to Java. Well, this is not the case with Groovy. So that's a big plus for all of you that are already working with Java. So let's see a basic example. And where's my pointer? All right. So you have a basic class. That property, the getter and the setter, we are following the convention. And we have a business method called grid. And we have our main entry point, right? Every class in Java has to have this. So let's look at the Groovy version of the same code. Link, and you'll miss it. Let's see it again. Java, Groovy. So first thing you learn about Groovy is that the syntax is almost equally the same as Java. And right now, those of you Java developers, raise your hand again, please. You have swallowed the red pill. You are now Groovy developers. You cannot go back, right? And this is why. Because you can, in most cases, rename all your Java source files into Groovy source files. And it will run, and it will compile, and it will do amazing things, which is actually what you're expecting. Here is a more Groovier example. So Groovy has a concise syntax. So you can use the Java syntax, or you can use this one. So we have the same class declaration. You can see that some keywords can be omitted because they are implicit. Everything is public. That is a property. And if you inspect the bytecode, you will see a getter and a setter. And this is actually a script, even though it's declaring a class. See, there is no main entry point. If you run this through the Groovy interpreter, you get the exact same behavior as the previous example done in Groovy and in Java. So we have less lines of codes. We are more expressive, but we retain the same behavior. This is one of the advantages of Groovy for you Java developers. You can have the same behavior with less lines of code. And the theory says if you have less lines of code, then you have less risk, and you'll probably have less bugs, right? Hopefully. I forgot to mention, if you want to ask questions as we go along, please do, or if it's a really burning question. If not, then we can wait until at the end of the session. So the first thing you have to take into account when working with Java and Groovy, this is the first mantra. So Java is Groovy, and Groovy is Java. So what does this mean? It means that every single class, every single Java class is also a Groovy class. And every single Groovy class is also a Java class. You can call Java from Groovy and call Groovy from Java. And you don't have to use any sort of special bridge, let's say the Java Access scripting engine that came from the Java 6 release. You don't need it because Java and Groovy integrate seamlessly, just like that. There are other JVM languages like Ruby that can call your Java code easily, almost like there is no difference in the syntax. But if your Java code wants to call your JRuby code, then it's not exactly as easy. They're working on it, and hopefully some other languages will pick up what Groovy already provides. It's a seamless integration within the two languages. Groovy is also using the same memory model and security model as Java. That doesn't happen with other languages, let's say Jython and JRuby, because those languages are a port of native implementation into the JVM, and that's good for them. But Groovy has its roots in the JVM. So if you have something in production code that relies or has a specific ties into the Java language, memory model, and the security model, then don't worry. Those constraints will still work if you're testing your code with Groovy. There's no impedance mismatch there. So as I previously said, 98% of the code of Java code that you already have will work in Groovy. You just rename the file to .java, from .java to .groovy, and you're done. Now, what about that 2% that it may not be Groovy code? So here are a couple of gotchas. Java write initializers are not supported. That is because how Groovy treats the syntax for closures. But you can coerce a list that we have basic native syntax for lists. You can coerce any list into an array. So it's like you have to do a casting. And it's very simple to do casting with Groovy. It also is, right now, it's not supported inner class definitions. How many of you love working with inner classes? 3 people work. They're useful, right? I sometimes use them to define, I use my container class to define a namespace for those other private helpers. And I use my internet classes as private helpers, right? But let's face it, even James Gosling said before, the inner classes in Java are halfway through having real closures in Java. So because we already have closures in Groovy, we can forego having support for inner classes for the time being. So maybe in the near future, we'll be supporting inner class definitions. Let's go to the second mantra. And this is taken from my friend Scott Davis, an excellent person and a Groovy aficionado. Groovy is Java, and Groovy is not Java. What do we mean by this? Didn't we just say Groovy is Java, Java is Groovy, right? So this second mantra is contradicting the first. Well, actually, no. Because Groovy provides you with a flat learning curve. I mean, you can start with Java syntax right away using Groovy. And as you feel more comfortable with those features provided by the Groovy language, you can move on into a Groovier syntax. Remember the first HelloWorld Groovy example and then the second one? So when you are more comfortable with those features, then you will be writing Groovier code. But you can start with the syntax that you're already familiar with. Also, Groovy delivers many features that are very useful, and actually very useful when you are doing testing. For example, closures. Metaprogramming capabilities. We have new operators. We have operator overloading, finally, in one of the languages of the JVM. This is one of the features that many people ask to James Gosling to add eventually to the Java language, but we don't have that in Java. Well, we have that in Groovy. We have enhanced POJOs because if you declare a property, then everything else will be handled by the compiler, all the bytecode required for you to adhere to the Java Beans convention. But it's done by the compiler. It's not done by you. It's not done by your IDE. It's done by the language itself. We have native syntaxes for maps and lists, so it's easier for you to create those structures. We have regular expressions. We have enhanced class casting because, as I said, you can cast a list into array of anything you want to. We have optional typing. That's what I said. Groovy is a dynamic language. Remember that? Well, Java is a statically typed language. And Ruby, on the other hand, is a dynamic typed language. But Groovy sits in between. If you need types, use them. They're useful. But if you do not use them, if you don't need them, then don't use them. I mean, you can use doc typing if needed. That's why we call it optional typing. And well, this is only a handful of features that you can find in the Groovy language, but there are many, many more. So let's go directly into testing and why we are proposing Groovy for testing. So the first thing is that any Groovy script may become a test case right away. The only thing that you have to take into consideration is using the assert keyword that was introduced in Java 1.4. In Java 1.4, if you want to use the assert keyword, you have to set a flag, right? Enable assert. While in Groovy, you don't have to use that flag. It is enabled by default. And that's it. It's the simplest way for you to create a test case. The second one is integration with a testing framework. Because let's face it, if all of us use simple scripts for testing, then what will happen with those testing frameworks? Actually, we need more because not all applications are born equal. Not all software is equal, right? So Groovy provides a base Groovy test case for you if you want to use JUnit3.x series. And that test case has some features that you may want to use, and I'm going to show them. Also, you have a good level integration with Unit 4 and TestNG because Groovy is one of the few languages, actually I believe it is the second language, that has full support for Java file annotations. And also supports static imports, same as Java 5. And also supports enums that came in Java 5. This is how we usually test exceptions in Java, right? Probably we extend a test case if we are in Unit 3. And that is the business code we want to test, right? And everything that is in blue is the scaffolding that we have to code in order to assert that that business code is throwing the expected exception, right? So it's kind of awkward to have a catch block that does nothing. I mean, many tools will warn you against this, right? You should do something if you're catching an exception. Well, there's no other way for you to test this thing. Let me show you a Groovy way. So we extend the Groovy test case, and we use a new feature, which is the should fail block. It takes a class or a list of classes and a closure as a parameters. Look that the business method is inside a block. That's a closure. When the test is executing that block of code, and if that block of code throws the expected exception, then we're done. There is no need for that try-catch block. It's done for you. And actually, if you set a list of classes of expected exceptions, different exceptions that may be, it will also work. Because if you want to test that case, throwing several expected exceptions, then you have to have several try-catches block, right? Or at least several catches. And, well, it looks cumbersome. And the problem here is that it adds a lot of visual clutter. And if we really want to test things faster, easier, then we have to read them in an easier way. Yes, question?
Is should fail a keyword, or is it just a method that gets called with this closure?
Actually, it's a method provided by the Groovy test case. So how do you run your Groovy test? Well, there are plenty of options, and we support almost all flavors. We don't mess in any religious debates if one IDE is better or the other one. You want to use IDEA? Go ahead. Actually, IDEA has, to this date, the best support for Groovy right now. It evenly provides refactoring support within Groovy and Java source code at the same time. Well, you can also run Groovy on Eclipse or NetBeans, or you can use command line tools if that is your thing. Actually, I'm a Maven fan. So, but you can use Ant, you can use Gantt, which is a Groovier version of Gantt, of Ant. How many of you love working with XML? Come on, be honest. Really love. Okay, 5 hands. How many of you hate working with XML? More than half. Now, you know what's bad with Java? Since Java was born, it came with this, how can we call it? Like symbiotic twin that is called XML. Because every time that we want to, that we need to write configurations for our Java applications, what's the first thing that we think of? Is it properties file or XML? XML? Right. So what's up with that? Okay, Gantt is it's like a next level of abstraction over Ant. It removes all that XML thing. I mean, XML has pointy things. And if you really like to work with pointy things, then you're going to hurt yourself. Come on, stop hurting yourself. So Gantt removes the pointy things out of the way, and you use Groovy. So the next thing that you learn about Gantt and Groovy itself when removing XML is that, is XML a compilable format? You can compile XML? You get compile errors with XML? No, you don't. You get runtime errors with XML. Well, if you use Groovy as a DSL for driving Ant, which in this case is Gantt, you get compile time of your build files. That's good. At least that is the first line of defense against some type of errors, because let's face it, if we are developing software for removing bugs in production, we really don't want to create bugs on our testing software, right? So let's get those out of the way. Or if you don't are into these tools, you can also use the Groovy shell and the Groovy console and the Groovy interpreter. I mean, there are plenty of options. Actually, I really recommend all of you, if you want to start with Groovy, fire up the Groovy console. It's an UI application. It's let's call it a mini IDE, if you will. And you can replay all your scripts. You can save, you can load, you can do many things there. And it's very easy to use. Okay, mocking with Groovy, another hairy topic. How many of you are comfortable with EasyMock? Okay, a little bit. And JMock? Okay, less people. Don't worry. If you go with EasyMock or JMock, it doesn't matter. You can use them right away with Groovy. And that is because, as you can recall, any Java library can be used with Groovy right away. No problems there. But if you don't want to depend on an external library or external software because, I don't know, there maybe is a policy in your company to reduce the amount of dependencies for whatever reasons, which is maybe valid, then you can use Groovy by its own. I mean, you can create dynamic process as stubs. Groovy makes it very easy for you to create a proxy from any class. And I mean, even final classes can be proxied by Groovy because Groovy has these metaprogramming capabilities. Do you know that there are new methods that Groovy provides to string? Yeah, we do. We provide the capitalized method. We provide a new split. We provide each, which is an iterator over all of the elements that conform to the string, which are the characters. But if you look into the definition of the string class, it is final. So how come Groovy can extend the behavior of a final class? This is done by metaprogramming. We have compile time metaprogramming and runtime metaprogramming. Both are powerful, and you can use both of them as you see fit. Well, dynamic proxies use this feature, metaprogramming. And we can also use stu4 and mock4, which are pretty much designed in the same way that JMock works. But they do not have any external dependency. It's all Groovy. So let's see them in action. Let's go to a quick demo of dynamic proxies. Where it is? Okay. Let's fire up the Groovy console. Like this. I'm going to up the font in just a second. Let's see. Where's my Groovy console? Okay, there it is. Let's pump it. Larger font, larger font. Okay. So let's look for our example, which should be projects. No, sorry. Whoa, whoa, desktop. Where are you, desktop? Here it is. Dynamic proxy sample. Is that good enough for you guys at the back? Can you read it? Okay, so we have a basic class there, which is a string provider. Let's think of it like a regular service that you will use in your production code. And we have a string decorator, which uses this string provider. So the decorator is the color, and the provider is the collaborator. So whatever the provider returns, the decorator will add something to it. Here, here's where we define our dynamic proxy. So how many of you said that you work with JavaScript? Raise your hands, 30%. This looks like JSON, right? What we're actually doing here is converting a map into an instance of a particular class. So this is the syntax for a map. This is the key, and this is the value. The value is a closure. And then we are saying, Groovy, please, Groovy compiler, please transform this map into an instance of a string provider. And if you do an instance of on that value and on that variable, which is provider, it will say, I am a string provider. I am no longer a map. I am a proxy of a string provider. So you can pass it around to any Java code that requires a string provider. And that's it. I mean, let's use our decorator here. This is another nice feature of Groovy. Remember that I told you about enhanced POJOs. Not only do we provide properties out of the box, we also a nice default constructor that uses that property support. So that looks like name parameters. So we have a trick in Groovy to fake out name parameters. That's actually a map. So let's run this thing. Let's click on the run button right here. And no errors. That means it worked. I mean, this is a script. Let's change something here. So our decorator will always append the decorated string to anything that the provider gives us, right? And in this case, our provider will always pass Groovy. Let's change this to Groovy 2. So this assertion should fail now. Right? Assertion error. That's what you get out of the box. This is not a JUnit test kit nor a test engine test kit. This is a basic Groovy script. This is how easily you can test anything. Questions? Yeah, sir.
Mock built-in Java classes the same way or only Groovy classes?
You can mock anything. Java and Groovy classes this way.
Why did you use a closure to define getString in the provider? Why not just return the literal Groovy 2 or Groovy?
Because you are actually providing the implementation of the method.
Okay, cool.
So if you set a value, it won't work. You have to set a closure. Actually, that's how this mechanism expects you to provide the behavior for all these classes. So that's a good point. Yes, sir.
When you're mocking a class, do you have to mock all the methods of it?
When you're mocking a class, the question is, if you're mocking a class, do you have to mock everything? No. You just only mock what you need to. So let's say that our string provider has 10 methods, and we only care about this one, the get value. We create a proxy, and we define just the implementation for get value. So as long as you do not call the other 9 methods, everything will work. Everything will be peachy. Yes, sir?
Can you mock methods with parameters?
Yes, you can. You just define the parameters on the closure. For example, let's say getString takes a new parameter, string A, and we return A plus this one. Or, yeah, sure, let's do that. Let's say anything goes here, B. Groovy plus B plus decorated, right? You following me? Am I going too fast? Let's go. Wait, we're not. We have to set a new value here. We can define types, as I said, optional typing, or just set anything here. Let's say a character, whatever. Provider, string, character, and this guy has to be called getString, right? So right here, we call getValue. Notice that previously it was just value. That's because we are accessing the property right away. But if the method that looks like a property getter requires a parameter, then we have to use the long way, which is getValue and set the parameter. So let's say Google. Now this should be Groovy Google decorated. That's what we are expecting, right?
The question I have left is, what about two methods of the same name which differ in their parameters? You can't map those to separate values in the map.
You can't with this feature. This out-of-box proxy creation thing cannot work with that. But, and here goes a plug, there is a project called Proxyomatic, which I am the creator, that allows you that.
Excellent, thank you.
Thanks.
Nicely
Have
done.
fun. Oh, sorry. Well, we have a red bar. That's good, right? Red is as good as green. Now, we're green. Yes?
You said there was an Eclipse plugin. Can you use the one plugin to run like a heterogeneous collection of both data and Groovy types, or do you need to use one plugin for each?
Actually, the Groovy plugin for Eclipse has a good integration with JUnit and TestNG. It provides both. Okay, let's move on because I think I'm falling short in time. Everything is fine?
You have 25 minutes.
Oh, plenty of time. Whoop. Okay. So in case the demo gods were bad to me, this is how we will see the demo, okay? Hopefully that wasn't the case. That's good. Okay, so this is how stuff and stuff for a mock for work. We are, again, in our basic color collaborator way of working. Mocks and stuff define expectations on collaborators only. Mocks are strict. You define expectations on them, and you are expecting those expectations to be fulfilled in the same order as you define it and in the same cardinality. If you say getString should be called twice, then if your test, or your caller actually, doesn't call getString twice, then there is an error. And stubs are a little bit looser than mocks. You can, well, actually the expectation must be fulfilled in cardinality. So the same, they have to be, if getString is defined to be called twice, it should be called twice. But you can call, let's say, getValue between those two invocations. And that will be fine with stubs because they are loose. But here there's one caveat. Somebody asked me, these proxy stubs things, do they work with Java code and Groovy code? Yes, they do. But a stub for and mock for do not work in all cases. The caller must be Groovy. And that is because of how Groovy handles metaprogramming. Java code calls, whenever Java code calls another Java code, it goes directly to it. There is no way to do dynamic dispatch. But when Groovy code calls other Groovy code or other Java code, there is a chance for dynamic dispatch. And stub4 and mock4 rely on that dynamic dispatch. Let's look at it. Stub4 sample. Okay, so we have to do some import here. We are back to our string provider. We have now a string decorator, and the thing that changed here is that the decorator, which is our color, is creating an instance of our provider. How can we mock that? Actually, it's the same thing as if we have those evil singletons. How do you work and test with singletons? Well, if your code is Groovy, you can. You create a new stub for your string provider that will tell Groovy to do some meta programming magic. Then you declare your expectations on your stub. You say stub.demand, the method getString, if the parameters of getString had a number or a range, then that's how you will define the cardinality. By default, it's 1. So there's no point in adding an A1 there. And the closure is, again, the behavior of your expectation. In this case, well, you just return the string. We have optional keywords, remember? So return is an optional keyword here. The last evaluated sentence will be the return value. And now we declare that we have to use our stub. And that use method, which looks like a keyword, actually is a method that takes a closure as a parameter. And this is the business case that we want to test. We define a new instance of a string decorator. Under the covers, Groovy will do dynamic dispatching to our stub of a string provider instead of the real string provider class that we have on our color. So this code should work. Let's run it. No errors. Looks like magic. It's magic. It's Groovy metaprogramming.
If you nest calls to use, do you get multiple stubs active?
You can nest them, but as long as you do it in the correct order. Okay, next. Okay, again, if the demo gods were not good to me, this is what we will say. Testing databases. How many of you test databases? 40% of you. Any of you use DevaUnit? 3, 4. Well, I really recommend you to use, at least give it a look. I don't know which tools you use. Obviously, you can use whatever you need to or want to, but I really urge you to take a look at DevaUnit, which is an extension of DevaUnit, JUnit, sorry. How many of you know that you can run JUnit tests with TestNG? TestNG is the new generation of testing frameworks. So you can use DevaUnit with TestNG. There's no need to switch completely to another context. And there are several options at your disposal whenever you want to use DevaUnit for testing. You can go old school, which is extend a database test case. Actually, we have 5 base database test case classes, depending on how you will initialize the properties for the connection of your database or your data source in that case. There is also a more flexible option, which is using the iDatabase tester implementation. This option allows you test composition. So let's say you are writing an integration test with HTTP unit or any other JUnit extension that makes you extend a particular test case. Can you use DevaUnit now? No, you can't, because Java has single inheritance model, right? But if you use composition based on the database tester, then you can do it. Or the third option, for those of you that feel that you need to create your own tools, you can roll your own database test case. Remember what I said about XML? Okay, here it goes again. This is a basic implementation of a DevaUnit test case. Notice that it is not extending a test case, so I went with option number 2. I have an eDatabase tester as the object that will be responsible for reading, accessing, and writing to my database. There are 2 methods that are important in this case that are marked with those annotations before class and after class. So they are going to be called just once for all our test suite. That's a good thing. I know JUnit 4 has this feature, but it was done before in TestNG. So we create a new tester there. There are 4 basic implementations. Then somehow we insert the table schema, and the next thing you will do is fill the data. What happened to that XML? That XML is right here in your Java code. We're using here docs, as in Ruby, as in Python, as in C shell scripts. We have support for here docs. Just use the triple quote notation, and you can put anything there. It also has variable substitution. We didn't use variable substitution here, but it's very powerful. So what's the advantage here? If your test data is small enough, it can fit in right there into the source code or your test. Because sometimes you will be doing some tweakings to your test code according to your test data. If your data is huge, then obviously this approach is not really recommended. But we are still working with pointy things. And remember, we hate pointy things. Can we do better than this? Yes, we can. How? Let's turn it into Groovy code. This piece of code, the blue one, provides the same output, which is an XML file. Well, actually an XML string. But the advantage here is that that is Groovy code. That is code that can be compiled. That is code that can be debugged. It's hard to debug XML. I know there are some tools that provide XML debugging. Nobody likes to do that. Well, it's easier to debug regular code, right? So remember that I told you about DSLs? Well, Markup Builder actually is one of the many options that Groovy has that follow the builder pattern. And the builders are a good way for you to create DSLs. So this looks like a DSL for our data, because we're defining a company object or company bean with those properties, and that employee, which also belong, those two belong to another bean, which is the dataset bean. That is a container of these objects. And as far as dev unit is concerned, that dataset value is an XML string. Right? All right. We are actually finishing this thing. So functional UI testing. How many of you test your UIs in any ways? Okay, plenty of you. I assume most of you do web development. Is that true? How many of you do desktop development? And those of you don't keep your hands raised. How many of you tested? All right. Hopefully it's good for you, because I know it's hard. Okay, these tests usually require a lot of setup. And they depend on the environment like no other test. And this is one of the things that I think is inspiring by James' talk. Having your test and your environment coupled in a cohesive unit that can be repeated in any other place, that's good. Well, let's see if we can get there. Hopefully, we will get there. Actually, non-developers usually like to drive these tests because it is the customer, the end user, that will be using your UI. It's not us engineers, it will be them. Developers usually don't like to code these tests because of the same reason, because it's at the end of the production line of what we think is the end of the production line. When we ship it, we're done, right? Unless we receive a bug report. Non-functional testing means unhappy customer, and that means unhappy developer. I don't have to convince you on that. Well, Groovy to the rescue. You want to be happy again doing UI testing? You can. You can use any of these options with Groovy, with great success. If you're into web testing, you can use Selenium, or you can use Canoe Web Test, which I will say is my favorite. Because of the same reason, instead of using XML, if you don't need to, if you don't want to use XML, you just use Unicode as your testing DSL, and it will work. Or if you're into swing testing, I suggest you take a look at FEST, which stands for Fixtures for Easy Testing. Or if you're into the next generation of testing, which is behavior-driven development, then you can use ECB. And ECB works wonderful for any Java code and any Groovy code. So we're going to see an example of ECB and Fast in action. Hope you guys like it. Now we're into the, whoa, oh, that was an exception that we previously had. Whoa. Let me show you first the application. It's a very basic application. Let's go here. Let's go to desktop, GTAC. GTAC sample code. Let's open this up. Sorry, there's one level that I have to do. Oh, desktop, GTAC sample code, ECB fast, right. Source, right here. So let's run the application. Assume that we have a dictionary of words. The dictionary of this application just has one word, which is pugnacious. Yay, it means combative in nature, belligerent. Let's see what happens if we type anything else. The word doesn't exist in the dictionary. What happens if we don't type anything at all? Please enter a valid word. So these are the three scenarios that we have to test. How can we do it? That would be source, test, Groovy, swing, word finder. Can you look at the back? Okay. Oh. Some basic setup there. This is how you can set up fast, but the actual meat of our test are here. 3 testing methods. We will inject some value into our text field. Then we will click the button, and then we will assert that the return message is the right one. So first we will test if the word that is found in the dictionary actually exists. Then we will test if we don't type any value into the text field. And finally, we will test typing gibberish into the text field. This is good for us engineers. I mean, many will understand this right away. What happens with the customers? Can they understand this? Will they understand this? Would they like to understand this? No, they don't. They would like to see a well-formatted document with all the scenarios and the stories and in a very readable fashion, right? We cannot give them this, but we can give them something else. Let's go up to here. This is the same testing code, but it is using this framework, which is called ECB. Now, it has the same testing variables as the previous one, but you can see some new things like a scenario and some definition. And given that WordFinder's UI is shown some code, and the user types the word pugnacious and then some code, and the user clicks on the find button, and then we click on the button, then the correct answer is displayed, and we said, well, we're expecting combative in nature and belligerent. And then we have the code that actually does that. And finally, the UI will perform its cleanup section. This is one scenario of a story that has many scenarios. Actually, we have 3. So what we have done here is split the code that is understandable by the developer alone into some code that can be understood by customers and developers alone. And I'm going to show you what's the output of running this thing. Let's ramp up a little bit the font so you guys in the back can see it. Whoa, whoa, whoa. Okay. Let's run the developer test. Sorry. That doesn't exist. No, that does. Yay. 3 tests run, no failures. We're happy. So what about the customer? Now we're running the second version of the test. Okay. And if we look into our output reports, we have one story.txt file. What's in there? Let's look at it. Oh, sorry. Wrong command. This is what you will give to the end customer. Anybody can understand that. I mean, the user can give you this description, and then as easily you can translate it into ECB code, and then fill in the gaps with your testing code. And now both camps, the customer and the developer, are happy. There is more to ECB than this thing. This is a very basic example, but you can mix it with anything else coming from the Java world. Okay, let's finish this thing. So for more information, you can go to the project site, which is groovy.codehouse.org. There are some references for the testing frameworks and the test code that we have seen: unit, test-ng, Dev unit, ECB, and the last one is the page is the project page for FAST. And if you care to know more about Groovy testing, Groovy Swing, then you can read more about that at my blog. Actually, I blog a lot about Groovy and Swing, a little bit about FAST. But yeah, that's it. So, questions? Do you have questions, or you guys hungry? Doesn't work? That's a good question, which comes up a lot lately. I have good news. Groovy 1.0, which came out December 28, something like that, of 2006, had a good level of performance. But if you compare it to Java, it was bad. Now, Groovy 1.5, which came out at mid of this year, has way much better performance. And it's faster than JRuby. The latest beta, which is 1.6 beta 2, has even faster performance than 1.5. But you have to bear in mind, Groovy, because of these meta-programming facilities, has an abstraction layer over those calls. So Java code calls directly your Java method, but Groovy does some meta magic to do that, some dynamic dispatch. So that layer is getting very, very faster, but it is still a layer up from your regular Java code. So it's never gonna be the same wave of, it won't have the same performance as Java in terms of speed because of that small layer. But it's getting faster.
Okay, so testing. Sorry. So if I have 100,000 of tests written in the Java, should I forget about Groovy?
No, actually, you can just run it with the Groovy interpreter most of the times. If you're not relying on inner classes, you are not creating inner classes in your test, then you can use Groovy. If you are not using array initializers, you can use Groovy right away. And if not, when you're trying to compile those classes with the Groovy compiler, you will get some errors and some warnings of what syntax is supported and which not.
Thanks.
Yes, question.
You
Yes, Maven, correct.
So how would you run a dependency?
Yes, you will add the Gmaven plugin as a dependency, and then add some configuration in your report section. And also, I think that will be all. I mean, it's very easy. And one good thing about the Gmaven plugin is that it not will only compile your code, run your test code, it will also give you a Groovy shell, an interactive Groovy shell, and an interactive Groovy console that will load all your class path, all your dependencies. So you can do interactive testing on your application as you go with this plugin. Yes, question?
I want to start by saying I'm a big fan of Selenium's approach of trying to make commands as readable as possible. Looking at the final example you showed there, you had human-readable, non-programmer-readable text, which basically functioned as a comment or an annotation on the actual Ruby code that was driving the test.
Can we see that?
And
Yes.
when I see that, I worry immediately that they'll get out of sync, that somebody will make a change in one and not in the other, and your test stops being representative of the customer's intent, and the feedback becomes inaccurate. Is there any effort in Groovy to construct testing frameworks that give you more directly human-readable test commands in a Selenium-like style so that you don't have that separation between what the customer sees and what the code sees?
Not that I'm aware of right now. I mean, ECB is the latest batch, but they may be probably somebody thinking already in that or probably doing some code. But I'm not aware of somebody actually that has made it public yet.
There's some work on an application called Telenium.
Tellurium, is that it?
Telenium,
Telenium?
which sits on top of Selenium, and it's
Okay.
Groovy based. And so I was wondering, are you familiar with that?
No, I haven't seen it before.
There's a Yahoo group on that.
Okay. You can also use ECB with Selenium, I believe. And if you're into web application development, and obviously you have seen about, you have read probably about Ruby and Rails, we have our own version in Groovy, which is called Grails. And there is an ECB plugin for Grails that works in a wonderful way, similar to what you have seen here with Fast. You just add Canoe Web Test or Selenium with your Grails application, and you're done. You're in business.
Hey.
Question?
Do you have any inbuilt support for multi-threaded test tracks?
Multi-threaded test tracks. Not in Groovy alone. You will have to rely on any existing Java library right now.
Hi, got a couple questions. First, Groovy is able to reach into the private members of Java classes.
Right.
Is there anything you would say to kind of assuage the fears of certain developers that it's still okay to write tests in Groovy for Java code because it has that additional capability, which I would actually like? And my second question has to do with just the readability of test results when exceptions are thrown by any testing framework. They're usually pretty ugly in Groovy. They include lots of extraneous entries. Have you found a way to kind of make those more readable?
Okay. First, on your first question. Sorry, what was the first question? I was thinking already on the answer in the second one.
Just how to calm fears about
The private thing.
Yeah.
Right. So Groovy can see your privates. That's a funny comment. Yeah, right. Actually, that is a feature. That is not a bug. That is an intentional feature. That is an intentional design. Believe me, it's not a bug. It's a feature. So why would you let developers access private data on your class under test, right? There are some times when you really need to do it. But most of the times, if you had a good design, if you follow the test-driven development design, then you will not have to rely on those private things to be tested or to be set into a proper state in order for you to test it. But that comes with experience. Yeah, I will say, yes, you can do it. You can inspect the privates of any class, but try not to do it. There are better ways for you to test your classes. But if there is actually no way for you, if you're working with legacy classes, with legacy data, that you cannot change the source code, and this is the only way for you to set the proper state and then invoke the class, then do it. It's the only way. And the second question is about stack traces. Again, because of this metaprogramming abstraction layer, you will see many intermediate calls within point A and point B. And then you can get huge stack traces. You can register perhaps, actually the Groovy shell and the Groovy console already provide means for you to filter them out. But the Eclipse plugin also provides ways for you to filter those stack traces. What will happen if you run your Groovy code in, say, Hudson, a CI integration environment? I will suggest take a look, if you're using Log4j, take a look at making your own appender to filter out those stack traces. It's not that hard to do, and I really wish at least Log4j implementation provide out of the box something like that. They don't. There is a patch somewhere to do that, but it's not taken yet. Any more questions? One more question.
Do we have Groovy drivers available for the Selenium?
Sorry, Groovy?
Drivers available for the Selenium. For example, if I want to export my test cases from the Selenium IDE to Groovy instead of Java. So just like you mentioned that just change the extension from .java to .groovy. Right. But if I don't have the drivers, I won't be able to run those Groovy test cases.
Well, I'm not really sure about that. I'm not a real user of Selenium, but I will expect somebody to have done something like that. I believe in you can read at the mailing list because somebody has already done some integration or some level integration with Groovy and Selenium. Or probably something can be refactored out of the Groovy Selenium plugin for Grails, which does what you need.
Okay, thank you.
Okay. I think that will be it. That's a wrap. And thank you guys for being here. I know you're hungry. Let's enjoy the lunch.